The first example this morning on implicit differentiation will be the following. We have a function looks like this. Y equals x to the fourth, I'm sorry, again scratch that, x to the fourth plus y to the fourth equal 16, and we are required to find the second derivative, y double prime. Okay. So as we did yesterday, we start with implicit differentiation. We're going to say that d dx on the right side, on the left side, we're going to take the derivative of x to the fourth and plus y to the fourth. And it's equal to d dx of the quantity we have on the right side, which of course the result will be 0 on the right. But on the left, power rule gives us 4x cubed. Power rule with respect to y give you 4y cubed. And then we have dy dx, or I'm going to use today the prime notation, so I'm going to write y prime here. Okay, and this equal to 0. And now I can keep this equation in mind. Well, maybe not. Let's simplify this. Of course, the 4 is being reduced. We can divide everything by 4, and then we end up having y cubed times y prime equals negative x cubed, and therefore we end up having y prime equals negative x cubed divided by y cubed. Okay, so we find the first derivative. We're going to use it later on, but I really don't want to use it. I don't want to take the derivative of y prime because I try to avoid the quotient rule. Remember, the goal is to find the second derivative. What I'll do now, I'll take this equation after we divide everything by 4. Okay, so I'll take the 4x cubed plus 4y cubed equals 0, and I write it as x cubed plus y cubed equals 0. I'm sorry, I have y cubed, y prime here. Okay, so in a second, let me correct what I wrote here. Okay, I'm sorry. Go back again. Ask again, please. What justify? Lead me to. Are you talking about this row or the 0? The y prime. If you differentiate with respect to x, y to the fourth with respect to x by the chain rule, the outside function will be y to the fourth. So the power rule with respect to y, dy4 dy is 4y cubed, but then you have dy dx, the inside function. So it's y prime. This is,
so you have to differentiate that?
yeah, this is the class from yesterday, which unfortunately you missed. Right? You missed yesterday?
No.
I'm sorry, I thought you did. Okay, going back here. Okay, so this is a comment. Okay, what is d dx of y to the fourth? Right? It will be d dy of y to the fourth times dy dx by the chain rule. You see that? So you take the derivative with respect to y, it will be 4y cubed, and then the derivative with respect to x is simply y prime. Right, right. Okay, so let's bring this here, what we were we start to do. So now we have the equation x cubed plus y cubed y prime equals 0. I want to do implicit differentiation, a second implicit differentiation right here. Okay, so you take the derivative on both sides, like so, and of course the derivative of 0 is 0, so that's just a matter of technicality. And apply the power rule, so you have 3x squared. Here we have a product rule and a chain rule. Okay, the product rule means that u is y cubed and v is y prime. So let's do u prime times v. The derivative of y cubed is 3y squared, right, times y prime, as we did here. And then we multiply it by y prime, which is which is v. So this is u prime and this is v. And then we have plus u v prime. Well, u is y cubed, and v prime, the derivative of y prime, is y double prime. Okay. Just to drive this point home, by the chain rule, if this is u, by the product rule, and this is v, well, this will be u prime, and this will be v, right? And this will be u times v prime. And all of this equal to 0. So let's start making sense of this. We end up having 3x squared. What do we have here? We have plus 3y squared, y prime squared, and then we have plus y cubed times y double prime equals 0. We want to solve for y double prime, right? Now, we are stuck with y prime, and we need to square it, but we already found out that y prime is negative x cubed over y cubed. Okay, so what we're going to do right here, we're going to plug y prime equals negative x cubed over y cubed, like so. Okay, so this will go to replace, and of course we need to square it. So let's see what do we have now. After the substitution, we have 3x squared plus 3y squared, and then we squared, so we lose the negative, and the square of x cubed, of course, is x to the 6, and then y to the 6, plus y cubed times y double prime equals 0. One simplification, we reduce, and we end up having 3x squared plus 3x to the 6 divided by y to the 4th plus y cubed times y double prime equals 0. Are you having fun yet? This is not an easy one when you take the second derivative. And I want, before I solve for y double prime, I want to eliminate the denominator, so I'll multiply the whole equation by y to the 4th to get 3x squared y to the 4th plus 3x to the 6th plus, after multiplying by y to the 4th, I have y to the 7th, y double prime equals 0, and now we bring it home. Y to the 7 times y double prime equals negative, we can write 3, pull it out and get x squared y to the 4th plus x to the 6th. We probably can factor out x squared as well. And then y double prime equals negative 3. I'll factor out x squared. There is good reason for that. If I factor out x squared, you have y to the fourth plus x to the fourth. This is the final answer. Well, if you give me this as a final answer, you get only half credit at the if I'm generous. And can you give me a reason why this is an incomplete answer? Look at where we started and look where we end up. Do you see a way to simplify? Precisely. Look at this quantity right here in parentheses. This quantity equals 16. This is where we started with. Okay, so you need to be mindful of simplification of this nature. So y double prime now, it will be negative 3x squared times 16 divided by y to the 7th, and the final answer will be negative 48x squared divided by y to the 7th, which is a much nicer, more compact solution than one would expect after going through the trial and tribulations of to get to this answer. Okay. So this is something that you probably are going to see on occasion, where you take the second derivative, or sometimes it will happen after the first derivative. You can simplify because you get back to the original equation.